Hello everyone. So in this video we will be talking about the complete voice agent. In few of the previous video we have seen the individual components. So we have seen the speech to text, we have seen the text to speech, we have seen how can we fine tune text to speech or speech to text. In this video we will see the complete AI agent in action. So let's first quickly see the demo and then we'll move towards the how I've developed it. So right now what I'm doing is I'm creating a call. I'm doing a call. So instead of an actual phone, I'm just using my browser. Hello.
I heard, hello. This is a placeholder response.
Okay, tell me.
I heard, okay. Tell me, this is a placeholder response.
अच्छा आप मुझे बाद में कॉल करेंगे एक बार, अभी मैं बिजी हूँ थोड़ा.
I heard, अच्छा आप मुझे बाद में कॉल करेंगे एक बार, भी मैं बिजी हूँ थोड़ा. This is a placeholder response.
Okay, so as you have seen, this is a call. So when I'm speaking, it's getting what I'm speaking, and then it's calling to LLM. So the LLM response is actually a hard coded response. I haven't actually called to an LLM. I have just hard coded it, which can be easily replaced by calling LLM. So speech to text, then the call to LLM happens, and then the response of the LLM is actually sent to the TTS, which I've already shown in the previous videos, and this is the fine-tuned version, and the output of the TTS is actually streaming over this and we are listening this, right? So this is a normal phone call. Okay, again this is not a production ready code, this is the hello world. I'll tell you how I've developed it and I'll tell you what all changes needs to be done to make it productized for production. Okay, so let's move to the code. Okay, for the purpose of this video, for speech to text, I have used the Deepgram. For text to speech, I have used MeloTTS, the fine tune. I have done the fine tuning of it and I've used it. And LLM response, I've already told you I've hard coded. You can easily change to OpenAI or some in-house LLM, right? There's one more component that we haven't talked in any of the previous video and in this video yet is the voice VAD, that is the voice activity detection. So this is the reason I have not used a whisper here and I've used Deepgram. So what is VAD? Is voice activity detection, right? So like I'm speaking, when do you speak over call? So someone needs to detect that the user has spoken, then the call should go to LLM and then the LLM should respond. So the end of speech needs to be detected. So this is the function of VAD. So if you want to do it, if you want to use an open source solution like Whisper, so if you're using Whisper, then you need to implement VAD. And for that there are two open source. One is the Celerio, which is I think one of the best VAD implementation which we can do it. So if anyone wants, they can just comment it and I will share the VAD implementation along with Whisper. But for the sake of this video, I have used Deepgram. So Deepgram does both of the things, STT and VAD along with it, right? Okay, so now let's move forward. I'll quickly help you understand my code. Yeah, so this is my client endpoint where the WebSocket gets started. Okay, so so as soon as the startup happens, I registered one async task, one background task, which is a process LLM queue. We'll come to it later, but again let's go to the WebSocket part. Okay, so as soon as my WebSocket gets connected, I just create the Deepgram connection. So this is the main component to it. So now Deepgram, what happens is Deepgrams gives, we keep writing it to Deepgram socket. This speech we are getting, we keep writing it to the Deepgram socket, right? And as soon as it emit events, and as soon as we events for the final speech, we call the LM, and which on the LM response we call the TTS, and the TTS response we send it to the stream again, either to call or to browser, whatever. Okay, so let's quickly move it. These are the options, these are the payload which we have to send to Deepgram while creating connection. So as soon as our WebSocket is getting connected, we are creating the Deepgram connection, right? So this is the Deepgram model. Nova 2, Nova 3 is already released, you can try it there. HI is the language for Hindi, which since we have seen, we have been able to uh, as we have been able to read Hindi and English both, so that's why I've used the language HI. This is the encoding. This is a sample that we are sending. Interim results I'll talk in a bit. VAD events I've already told you. VAD is needed for voice activity detection, end pointing, and utterance, and I will talk about it later. Okay. These are the events that gets fired up: on open, on close, on error, on transcript, and speech started, utterance, and okay. So let's talk about the events now. So as soon as the socket gets connected, on open, on close, on close. These are the simple events. On error, on some error, it shows events. So how does it detect speech and what are the events there? These are the important things, right? So first of all, as soon as we start speaking, it starts emitting event. These are the interim results, right? So what we have to do, we have to keep buffering the interim results until we get the final speech, right? So that's what we do. So on transcript is getting called with every, on transcript is when Deepgram is saying now I have the transcript. It could be interim, it could be final, right? So how does it tells that it is interim and it's not final? Is this is final? Is final can be interim, can be final. So that means on every interim and every final is final come. So what we have to do, we have to buffer every is final. That's what we have done. If we are getting is final, we are just appending it. Okay. So now we know how the interim results are coming. Now there are multiple ways Deepgram says that tells us the speech end has come. So one way is the on utterance end. So we have given this utterance end MS. Okay. So what does it says? What does it check? It checks the gaps between the words. So I'm speaking. As soon as the gap between two words is 1200 milliseconds, it detects the end of speech. This is their approach to manage the background noise. We'll talk about it in a bit later. Okay. So as soon as it finds the gap between two words as 1200 milliseconds, it emits the utterance end event, and there we have put these two messages to LM task queues. We'll talk about it in a bit. So basically, as soon as utterance end emits, what does it does? All the text it appends there, it just get it. We have get the all transcript, and we have put all the transcript to this LLM queue. Okay. Now there is one more way Deepgram tells that's the end of speech. So we have seen is final here, right? I'll show you in their blog. So Deepgram tells speech final is, so it is different from is final. So is final true comes for every interim results, right? Speech final true comes when the actual ending has happened. So this is one of their another way of showing that speech of end of speech has happened. So we have not used it here. Very simple. We could have used it. And what is the duration it gets? It use end pointing. So it detects whenever it detects 800 millisecond of silence, it emits the event speech underscore final, which suggests that speech end has been done. Right now, let's say you are in a noisy environment where people keep talking, some gibberish noise is coming from the background. It might happen that this end pointing never happens. That means you never get the 800 milliseconds of silence. So a speech final might never trigger, and hence the utterance end MS must be used. Okay. In production environments, ideally what is used is the combination of both. Since utterance end is 800 ms and end pointing is 800 milliseconds and utterance end is 1200 milliseconds, and utterance end has to be greater or equal to 1000. It cannot be less than 1000. Deepgram does not accept that. So that means when you use utterance end, there is a slight bit of latency added, right? So what we generally do in production, we use a combination of it. We listen to both. If we get the speech final, we process it. If it does not get the speech final, then we use utterance end. and we ensure we do not process both. I mean, these are the standard checks that everyone keeps. Okay, so just to summarize, deepgram, we have used the deepgram, we have used the end pointing and utterance and events. We have used the interim results is final, and we keep buffering until utterance and ms utterance on utterance and event emits. Okay, yeah, so that's all about the speech to text and VAD. Now we were here, we have put the two tasks to LLM task queue. Now we go to process LLM queue. So if the task send is send transcript, that means just send the transcript to the browser. As you have seen, the messages were coming here. So this is from this, and it's just writing WebSocket send text. So it's sending text to stream, which is the browser stream. Okay, and the second message is actual processing of LLM, which is the process LLM response. I've shown you that I've calling the hard coded response. So what I've done is I've just attended to history because we want to keep history while we are calling. Then we call this function call LLM, and this is the message I heard the user message, and this is a placeholder response, which is this I heard user message. This is a placeholder response, and you can easily replace this function by calling the actual LLM and get the bot response. Okay, now we move back to from where we were. Right, so we call LM, we got the LM response, we append it to history here because we want in the next turn also we want to send the complete history to the LLM, and then we are sending this, we are calling the text to speech engine for the text to speech. So this is our text to speech engine URL, and we are calling the text, and it's sending us the bytes, audio bytes. Okay, and yeah, we move back, and this is the TTS audio, and then we have sent this audio to in the base64 format to the browser, which just plays it. Okay, we back to process LM response, and this is done. This is the queue, and this keeps happening infinite. So sorry, the socket keeps on running, keeps on listening until we disconnect the WebSocket from browser. So that's it. This is the demo code. If anyone needs this code, just let me know in the comment. I'll give it to you. uh, there's few differences if you want to use it over the call. So let's say if Exotel that use the 8000 frequency, it uses the linear encoding, linear PCM encoding, so this will work. It's just when you're sending the final audio, it has to convert it into the bytes and all, but that's a straightforward. I mean, you can get it from the Exotel itself. Yeah, thank you. If anyone has any questions or query, please feel free in the comment. I would definitely try to help. Thank you.